Hello everyone, I am going to share some few details about the paper title A Comparative Study of LSTM-based Long-Term Electrical Load Forecasting Technique with Hyperparameter Optimization. So in the abstract, it is clearly mentioned the long-term load forecasting is crucial for reliable electricity supply, infrastructure planning and informed energy policies, ensuring grid stability and efficient resource allocation. So this particular paper deals with the long-term load forecasting in Coimbatore region in Tamil Nadu, India. So also the forecasting obviously involves some machine learning techniques, and how the machine learning technique comes into the picture, and what are the techniques we employ, and what are the performance of the particular techniques. Everything we will discuss in the upcoming section. So in the introduction we talk some background of the research, like what is load forecasting, what is the need for load forecasting, what are the technique we integrated in this particular work, like that. And in literature review also we talk about some few existing technique like ANN, LSTM, how they integrated in the load forecasting, and what are the performance of the existing technique. Everything is detailed discussed in the literature review. And in the proposed methodology we talk about the long-term load forecasting, also the technique like LSTM, long short-term memory technique, and what are the demerits of the particular technique while it is used individually, and what is the need for integrating optimization technique. Here the optimization technique is integrated to enhance the performance of the traditional LSTM technique. Like the exact purpose of the optimization technique is to identify the hyperparameters of the LSTM. That's what. And the optimization technique used in this particular work is particle swarm optimization, gray wolf optimization, underspray optimization. These three optimization technique are traditional technique. Among these three traditional techniques, underspray optimization technique preferred better results. So that's why we consider underspray optimization technique for the modification purpose. And we try to integrate opposition based learning (OBL) in underspray optimization technique in order to enhance the performance of the underspray optimization technique to identify the optimal hyperparameter for LSTM to get the better forecasting. So here below that we talk about problem statement, research objective, and the procedure of long short-term memory (LSTM) technique, and opposition based underspray algorithm. The entire procedure is shown there, in addition with the the flowchart also. So flowchart clearly details how it works and all. So in the fourth section, results and discussion, we talk about the performance of all the employed technique like ANN, individual LSTM, and then optimization technique configured LSTM. What are the performance and all we discussed. So it is clear in the graph from the figure 2 to figure 7. It is obviously clear that the performance of LSTM integrated with opposition based underspray optimization technique exhibit better performance in prediction forecasting. So it will give almost closest actual value. So in that case, in addition, we are also trying to project in mean square error, root mean square error, MAPE. In all the three categories performance, it is very obvious that opposition based underspray optimization used for configuring the hyperparameter of LSTM for load forecasting gives superior results over other techniques in standalone or other configured techniques. So in the MSE it is showing that the error value is 0.25, which is less than 1, and in the RMSE it is showing 0.5, and in MAPE it is showing 0.27, which is superior over other technique. That is what detail in the results and discussion section. And in the conclusion it is very obvious that this research having the significant impact. It offers the promising approach to address the challenges of load forecasting and holds significant implication for the power system industries. So this research will be very much helpful for the future researchers to put forth their own research and try to enhance the performance of the algorithm and come up with some better enhancement also. Thank you.